let's see how this works out. I haven't done this in a while. Alright, so over here we have a proof by mathematical induction. And I'm just doing this because I have a final tomorrow and I really want to practice PMI. Now, the statement is asking proof by induction, or proof by principle of mathematical induction, if you want to be, that for all n elements of the natural numbers where n is greater than or equal to 1, 1 plus 4 plus 7 plus all the way to 3n minus 2 is equal to n times 3n minus 1, all that over 2. Now, we're going to, over here, write the proof. And the first thing you want to do is set the base step. And we're going to have that where it is equal to 1, where n is equal to 1. So n equals 1, and we're going to have the left-hand side being 3n minus 2, right-hand side being n times 3n minus 1 over 2. Now let's see the right-hand side. Plugging in 1, you get 3 plus times 1 minus 2, which 3 times 1 is 3 minus 2. What is that? 1. No way, I said that. And over here, plug in 1. We're going to have 1 times 3 minus 2. Sorry, not 2. 1. All that over 2. Now, it's kind of hard to see. I don't know if you're able to see it. 3 minus 1, that's 2. That is equal to 2 over 2, which is equal to 1. Therefore, the left-hand side is equal to the right-hand side, and we are good to continue. Now, we're going to do the induction step / the hypothesis step. Now, the first thing I'm going to assume is that, or for n equals k, implies n equals k plus 1. That's how I like to remember it. Now, I'm going to make an assumption. We're going to assume that 1 plus 4 plus 7 plus all the way up to 3k minus 2 is equal to k times 3k minus 1 divided by 2. Now we're going to start the actual step where we're going to rewrite it. We're going to have 1 plus 4 plus 7 plus dot 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 plus 3k plus 2, sorry, 3k minus 2, and then plus the n or k plus 1, which we're going to, wherever we see a k, we're going to plug in a k plus 1. So it'll be 3k plus 1 minus 2 is equal to, and you write this in 2 lines so it's easier to see, k plus 1 times 3 times k plus 1 minus 1 all over 2. And there. Now we can get started. So, all of this over here is actually just equal to over here, because we're assuming this part is true, so this can go over here. So we're going to rewrite this as k times 3k minus 1 over 2, and then plus 3k minus 1, or plus 1 minus 2, and that is equal to k plus 1 times 3 times k plus 1 in parentheses minus 1, all of that over 2. Now we're going to do a little bit of distributive property, and over here we're going to end up with 3k squared minus k over 2. And then we're going to distribute here, we're going to get 3k plus, or this we're going to have 3. So 3 minus 2 is equal to 1, so it's just going to be 3k plus 1. And then this is equal to, so over here we're going to distribute this k plus 1. We're going to, first we're going to distribute this 3k plus 3 minus 1, so it's going to be a 3k plus 2. And we're going to distribute this, is going to be 3k squared. This is going to be a 3k, so, and then 2k, so 5k, and then plus 2. And that is all over 2. Now we can move this over to the left side. We're going to subtract both sides by 3k squared minus k. We're going to end up with 3k plus 1 is equal to 3k squared plus 5k plus 2 minus, and we're gonna, since this is a minus sign, we're gonna flip this, 3k squared. Since this is a minus sign, this is minus minus, we're gonna put plus, and we're just gonna have all of this over 2. Now, we're gonna combine like terms. We're gonna end up with 3k plus 1 is equal to, these 3's are gonna cancel out. This is gonna become a 6k plus 2 over 2. Now, we can take out the 3 from here, or the 2 if we want to, but what I'm just going to do is I'm just going to cancel this, make this a 3, and cancel this and make this a 1. So it's just going to end up as 3k plus 1 is equal to 3k plus 1, and therefore that's how you can know that this statement up here, theorem is true by PMI. And there's your proof. Here's the full thing if you want. I did this by myself, just by, like, I got the answer sheet, or the problem from a website, and I did the answer by myself. So if you see anything wrong, let me know. But I believe this is right, and like I said, this is practice for an exam. So if I see something wrong, please let me know. Anyway, peace out. See you in the next one.